Okay, so question number 10. Is to write the full electron configuration of fluorine, atomic symbol F, and then write the full electron configuration of a fluoride ion, which is F-. How many valence electrons does a neutral fluorine atom have? Okay, so first let's write the electron configuration of fluorine. And the first step of writing electron configurations is to divide our periodic table into the different blocks. So we divide it into the S block, which is these first two columns, including the helium. And the P block is shown here in green. The D block is our transition metals in orange, and the F block are the bottom two rows, which are the lactanides and actinides. So when we write the electron configuration, we start from hydrogen, which is 1s, and then we move left to right across the periodic table, also showing the superscripts, which tells us how many electrons are in that orbital. So for example, for hydrogen and helium, this is 1s2. And then on to the next row, we have 2s2. And then moving across to the 2p orbital, we have 2p. And then we count out up to the fluorine how many electrons would be in this orbital. For a fluorine atom, we have 1, 2, 3, 4, 5. Okay, so 1s2, 2s2, 2p5 is the full electron configuration of a ground state fluorine atom. And now the question says to write the full electron configuration of a fluoride ion, so F-. So the difference between F and F- is that the fluoride ion now has an extra electron. This is why it has a negative charge. So when we have an extra electron, we can write our new electron configuration, which is 1s2, 2s2, and then 2p6. Okay, so you can see that it now has the same electron configuration as neon. So we can show neon in square brackets, kind of show that it's the same electron configuration as F-, meaning that these two are isoelectronic. So now the third part of the question asks, how many valence electrons does a neutral fluorine atom have? So neutral fluorine in total has 9 electrons. So if we count out all of the superscripts in our neutral fluorine atom, 5 plus 2 plus 2 is 9. So now let's try to show a diagram of this atom. So when we have a fluorine atom, we have 2 electrons in the innermost shell. So this is the 1s2 orbital. And then in the next shell, we draw the remaining 7. So therefore, we can say there are 7 electrons, or 7 valence electrons. So valence electrons refers to the electrons in the outermost shell, and you can see that it is the 7 that are shown here. So the junior tutor said that the electron configuration of an atom represents the arrangements of electron distribution among the orbital shells and subshells. It is used to determine the shape and energy of electrons in an atom. To write the electron configuration, follow the steps below. From the periodic table of elements, determine the atomic number. 2. Determine the charge of the atom. If it's neutral, there'll be no additional electrons. If it's cation, which is positively charged, then the coefficient of the charge represents the number of electrons lost. If it's an anion, the coefficient of the charge represents the number of electrons gained. Write the electron configuration, taking table below as a reference. Okay, so this is a helpful table to help write the electron configuration, and they just kind of summed up all the different sublevels and how many electrons will be found in each orbital. So for part A, they got 1s2, 2s2, 2p5 for neutral fluorine. And when we have a fluoride ion, which has a -1 charge, 1 electron was added, and they got 1s2, 2s2, 2p6. For part C, valence electrons are the electrons that can be found in the outermost shell of an atom and occupy the highest principal energy level of an atom. It can be identified by just counting the number of electrons, represented by the superscript, of the last principal energy level. For the electron configuration of a neutral fluorine atom, it has 7 valence electrons. Yep, so this solution is correct. Okay, so question